In this video, we'll look at analyzing quadratic functions in vertex form. In doing so, we'll find the vertex, determine whether it's a maximum or minimum, the line of symmetry, x-intercepts, y-intercept, then we'll put it together on a graph using the vertex and the a value. First example has us looking at y equals the quantity x minus 5 squared minus 1, and realize it's the same thing whether it's f of x equals or y equals. That's not going to make a difference. What we are going to recognize is we're going to match it up with the form of the vertex, which we like to use the fill-in-the-blank philosophy. So if that's the case, we have it looking like this. Notice our a value, there's no value there, so we can put a 1. So we'll match that up, a equals 1. It's minus h, so here's a, minus h, which matches up with 5, so that says that h is equal to 5. Some people like to look at this minus 5 and they'll say it's always the opposite. I like to think of it as the value I'll substitute in to make 0. And then our last value is the k value that we're going to look at, and that blank matches up with a minus 1. So the k value is negative 1. So we have a equals 1, which tells us the concavity because it is positive. A positive a value tells us that the shape of a parabola will be concave up, meaning our vertex will be a minimum value. If it was negative, it would be concave down and a maximum value. And our vertex is simply 5, negative 1. So that's quite simple. That's why we like vertex form. It tells us information right away. The next thing we can look at is the line of symmetry. The line of symmetry will always match the h value or the x value of the vertex, depending on what you want to call it. I'll abbreviate it L/S, and then I'll write it as a line, x equals 5. So we already have an idea of what this parabola is going to look like. It's going to be concave up. The vertex is a minimum, and we have a line of symmetry going through x equals 5 on our graph. The next thing we'd like to find is we'd like to look at the x-intercepts. To find the x-intercepts, you may recall that we set y equal to 0. And in doing so, we'll have our equation, x minus 5 squared minus 1 equals 0. So we'll go through our usual steps for inverse operations and solving equations. So we'll add 1 to both sides, leaving us with x minus 5 squared equals 1. We'll then square root each side. And this is where you need to remember that when you square root the value squared, it's going to leave us with two values. It could have been positive or negative 1. And we'll simply add 5 to both sides. And that leaves us with x equals 5 plus or minus 1, meaning we'll have 5 plus 1, which is x equals 6, and 5 minus 1, which is x equals 4. So we're almost there, almost ready to put this together. Last thing we'll find is our y-intercept. To find our y-intercept, we simply set x equal to 0, and we simplify or solve. So we'll have y equals 0 minus 5 squared minus 1. So that will be negative 5 squared minus 1, or y equals 25 minus 1, which is 24. Written as a point, that'll be 0, 24. Putting this together on a graph, we'll just do a somewhat rough sketch here. We won't label everything, so we're going to have the point, we'll call this 5. And we'll go down to negative 1 here. So we'll have our vertex down here. Now, in graphing it, the a value is equal to 1. When the a value is equal to 1, it will follow this pattern, 1, 3, 5, 7. It's the difference of perfect squares. So each time I move over 1, I'm going to follow the pattern. So I'd go over 1, up 1, which puts us at 6, which matches our x-intercepts. And then we're going to have a symmetrical value on the other side. And then when I go over 1, I'll go up 1, 2, 3. And I can identify that point as well. And if I go over 1, I'll go up 1, 2, 3. And we can see we have our parabola looking like this. And we'll see way up there, you know, you're going to have your y-intercept off our graph, which is at 0, 24. So very important, you do want to get used to this pattern for the a value. That's what's going to help you find the graph, and it'll help you match up the points as well. Let's look at a second example where the a value is not equal to 1. So that will be number 2 here. is y equals negative 2 x minus 3 squared plus 8. So again, immediately we can look at matching this up with vertex form. And then we'll notice that the a matches with negative 2. The h is a positive 3, meaning it was moved right 3. And the k value is a positive 8. So this negative a value tells us that it's going to be concave down. And it's going to be a stretch of 2, meaning it's going to be 2 times more narrow. And if we're concave down, quite obviously, our vertex is going to be a maximum. Our vertex, again, very simple. We're just pulling out the 3 and the 8 is 3, 8. The next thing we'll look to find is the x-intercepts. We'll just do that right here. So again, x-intercepts, we're setting y equal to 0. So we have 0 equals negative 2 x minus 3 squared plus 8. We'll start by subtracting 8. I'll do it to the left-hand side this time. It's not going to make a difference. If you're more comfortable setting equal to 0 on the right-hand side, go ahead and do that. This is where some students make the mistake of doing something with the squared, but remember, we're using inverse operations, so we're going to get rid of the multiply here, which means we'll be dividing by negative 2. That leaves us with positive 4 equaling x minus 3 quantity squared. And then from here, we'll square root both sides. Don't forget, it's going to be plus or minus 2, because when we squared the value, we don't know if we started off positive or negative. And our final step, of course, is to add 3 to both sides. And in adding 3 to both sides, we're left with 3 plus or minus 2, which brings us to our x values of 3 plus 2, which is 5, and 3 minus 2, which is 1. So we have our x-intercepts and our vertex already, and our concavity. Next up, we can look at our y-intercept. For our y-intercept, we will set x equal to 0. And when x is equal to 0, that leaves us with y equals negative 2, 0 minus 3 squared plus 8. So we just simplify this, 0 minus 3, negative 3 squared plus 8. And then realize we're just following the order of operations here. So negative 3 squared is going to be 9, so negative 2 times 9 plus 8. We have negative 18 plus 8, and we're left with negative 10. So written as a point, we have 0, negative 10. So you can see all the things we're going to look at to put together. We have our vertex here. We have our x-intercepts. We have our y-intercept. And don't forget, we have our a value of negative 2. That's going to help us graph it. So let's put all those together on the graph. So that will leave us with something like this. We'll have our graph. We'll make this a little better. 1, 2, 3. We'll go up 8. 1, 2, 3, 4, 5, 6, 7, 8. We have our point there. So we'll mark that off here as 8. Clearly see our 3. We see our x value. So again, our vertex was 3, positive 8. And we can go ahead and put our other points on right now, but I'd rather have us take a look at that a value of negative 2. So remember when I told you earlier that when a equals 1, we follow the pattern 1, 3, 5, 7 when looking for the changes between each point. So when a equals negative 2, what we simply do is we just multiply each of these values by negative 2, because that's how much it has been stretched and or flipped. So we'd have negative 2, negative 6, negative 10, and negative 14. And it doesn't matter if it's a fraction, a whole number, an integer, you're always going to go through the same process. So now when we go ahead and graph, when I go over 1, instead of going up 1, I'm going to go down 1, 2, and I'll have my point. And then we'll have a symmetrical point. Over 1, down 1, 2, and we'll have our point. So that would be at 2, and that would be at 4. Our next point, we're going to go over 1, and then we're going to go down 6. which puts us on the x-axis, over 1 down 6, and again, it puts us on the x-axis. And this matches the values we found earlier for our x-intercepts. And again, we can see if we go one step further, we'll be able to see our y-intercept as well. But this will be good enough for us here. And we have that problem taken care of. Let's take a look at another example, maybe not as much detail, but it's good to see. So in this one, we'll look at something that has fractions and numbers that could be considered a little scarier for some. We'll look at y equals negative 1/10, x minus 50 squared, plus 80. So for some people, this could be a little more difficult to graph, but again, we'll look at identifying everything, and then we'll do a rough sketch. So again, we can see here, our a value is equal to negative 1/10. Our h value is a positive 50 because we have minus, so the value I'd put in to make 0. And here, our k value is 80. So when we see a equals negative 1/10, again, we can see that the graph will be concave down, and it'll be 1/10. So it's going to be much more shallow, or some people like to think of this as being more wider. And therefore, our vertex will be a maximum. And our vertex is simply 50, 80. So in our rough sketch, I'm going to start off with that first. We're going to end up with something that is over 50 and up 80. So it's some random point up here. And if we needed to find more values, we have a equals negative 1/10. Now, if we compare that to a equals 1, our changes were 1, 3, 5. So in this case, it's going to be negative 1/10, negative 3/10, negative 5/10, and that's very difficult to find. So in some cases, rather than using the a value, you can also go and just use a table of values. So in using a table of values, I like to put my vertex here, 50, 80, and I notice that the a value is 1/10. So that divided by 10 bothers me a little bit. So rather than moving by 1, I'm going to move my x values by 10. So I'll go down to 40 and down to 30, and then I'll have symmetrical points at 60 and 70. And then if I substitute these values into the equation, let's just take a look at one of them. Y equals negative 1/10 times 40 minus 50 squared plus 80. Notice we'll have negative 1/10 times negative 10 squared. We'll go ahead and do that, 100 plus 80. Negative 1/10 times 100 is going to be negative 10 plus 80, which is going to give us a value of 70. So we'll have 70 on each side. We can go ahead and do the same thing with the 30 and the 30 and the 70 and have those values, but in this case now we can see, since it was difficult to deal with fractions, if we needed more points, we can do that. And then we'll see here we can have 70 if we were to make a nice scale. It would look a lot better. And then we can see what's going on with our parabola. Now, a lot of times we're interested in the x-intercepts, so let's go ahead and find those x-intercepts. So our x-intercepts, in this case, we'll set y equal to 0, remember? So we'll have negative 1/10 times x minus 50 squared plus 80 equal to 0. So again, we'll use inverse operations, so we'll subtract 80 first. Minus 80 minus 80 leaves us with negative 1/10 x minus 50 squared equals negative 80. So in this case, now we can either multiply both sides by negative 10 or divide by negative 1/10. It's up to you. I like to clear fractions, so I'm going to multiply by negative 1/10, and that will cancel. Multiply by negative 1/10, leaving us with x minus 50 squared equals a positive 8. Now we'll square root both sides. So in this case, notice when we square root both sides, we will not have a perfect square, and that's okay. So we'll have x minus 50 equals plus or minus the square root of 8. Some of you may notice we can simplify the square root of 8. It depends what your teacher's looking for and what you're looking for. If we were to do that, we'd have root 4 times root 2, which is 2 root 2. So we'll go ahead and use that in a moment. And in finishing this, we'll add 50 to both sides. And when we add 50 to both sides, we have x equals 50 plus or minus root 8. This will serve for better approximation, but if you're looking for an exact answer, we'll go ahead and write 50 plus or minus 2 root 2. And those will be our two x-intercepts. Our y-intercept, as you know, is found the same way. Let's just identify that there. So we have our y-intercept. We will set x equal to 0. And in doing that, we'll have y equals negative 1/10, 0 minus 50 squared plus 80. So in a lot of these, you may have a calculator to do your work, so that might make things easier for you. So in this case, we'll have negative 1/10. 50 squared is going to give us a value of 2,500 plus 80. So 2,500 times negative 1/10, the same as dividing by 10, we'll have negative 250 plus 80. This will leave us with a value of negative 170. If we were to go back and look in our graph, it's not always feasible to put everything on our graph. So that's why sometimes we'll just look at identifying it. We'd see our y-intercept would be way down there someplace.